Here we got a little bit of a challenging problem that we're going to solve by completing the square. So first thing I'm going to do here is actually add 20 to both sides so that my whole equation is equal to 0. And completing the square is actually very helpful in a lot of situations. This one, not one of them. When we were doing this problem, the reason this becomes a challenge is because my first term is x squared, which is great. My second term is an odd negative number, which makes this a challenge because really I need to split it in half, which means that I'm going to be at negative 5 halves x in both of these here. And so that then becomes negative 5 halves. So that's a 5 in my completing the square. And then to get to my bottom right term, I do negative 5 halves times negative 5 halves, which is just 25 fourths. Great, so wonderful. But really, we need to get from 25 fourths to positive 20 here. So I got to figure out what I need to add to get it all the way up to 20. So to do that, 20 minus 25 over 4, get a common denominator here just by multiplying this by 4 over 4. Subtracting to get 55 fourths. Again, not great. And so now my equation, after doing all of that, I now have x minus 5 halves squared plus 55 fourths equals 0. And so now solving this, I subtract 55 fourths. So x minus 5 halves squared equals negative 55 fourths. I take the square root of both sides. Let's do this in red. Square root of both sides. Plus or minus I, because it's a negative inside the square root. Boy, this is ugly. And adding 5 halves. So my final answer here, x equals plus or minus I root 55 fourths plus 5 halves. And now, like, I could even go into simplifying that a little bit more. I'm not. But this is just to show like why it's more work to do completing the square when it doesn't fit our specific needs, like the b value being even.